Ahrefs API is a powerful tool that lets you build custom backlink monitors, perform in-depth competitor analysis, and make Ahrefs data accessible to your entire team, eliminating the need for individual accounts. In this guide, I'll walk you through everything you need to get started, including a detailed implementation of Ahrefs API for a common use case. I'll also cover the limits consumption, because with so much data available, it's easy to blow through your quota faster than an intern exporting entire database tables just to see what's inside. To show you what's possible, here are two internal dashboards we've built using the Ahrefs API. The first is a backlinks overview that tracks all backlinks pointing to Coupler.io. It includes detailed metrics for each link and makes filtering a breeze, whether the link was built organically, obtained through a guest post, or secured via another exchange. Later in this video, I'll show you how to gather all the data needed for such a dashboard and connect it to a live report, so stick around. Another excellent use case for the Ahrefs API is building competitor dashboards. For example, we've created one that compares 50 pre-selected domains, pulling key metrics like organic traffic or keyword trends month by month. This dashboard makes it easy to identify the top and worst performers and compare vital metrics side by side. Sure, we could gather this data manually through the Ahrefs interface without an expensive enterprise subscription, but imagine the thrill of opening 50 individual reports and trying to make sense of it all. Fun, right? It's worth noting that the full capabilities of the Ahrefs API are only available to enterprise users. While you can run some test calls on lower plans, they won't cut it for building custom dashboards or collecting data consistently. Enterprise users start with 2 million credits, which you can find listed in your account settings. Right above that, you'll see your current usage, which resets monthly on your billing date. Need more? You can enable pay-as-you-go at $50 per additional million requests, or save a bit by pre-purchasing credits at $500 per year. Just a heads up, if you go with pay-as-you-go, keep a close eye on your usage. Those costs can add up fast. I'll discuss unit consumption in more detail a bit later. For now, let's dive into the documentation, which is as user-friendly and thorough as the Ahrefs interface itself. It provides detailed guidance on each endpoint, examples of how to use them, and descriptions for every metric you can pull. If you're not on the enterprise plan, don't worry, check out the free test queries tab for examples of what the API can offer you. For authorization, Ahrefs provides API keys, which you can create multiple of for different users or projects, for instance. Each API key is valid for a year, after which you'll need to generate a new one. The API uses standard authorization with a bearer token. Parameters vary by endpoint, but some common ones might feel familiar if you've worked with SQL. For instance, certain endpoints require a select clause to specify which fields to retrieve. While this might seem like an extra step, it's actually a benefit, especially for endpoints that return a lot of data by default. Filtering is often available with a where clause, offering precision in your queries. And if you want to sort results, the order by option is a lifesaver, perfect for pulling up the top 10 keywords or pages without sifting through thousands of entries. To find the endpoints you need, browse the menu or use the search bar at the top. For example, if I want to get a list of referring domains from Site Explorer, here's the relevant endpoint. At the top, you'll see the URL and the request type. To the right are the required parameters, marked with an asterisk, along with some optional ones. On the left, you'll find all available parameters with their possible values and defaults. You can inspect the sample response to understand the kind of data you'll get with this request. There are also sample requests provided in multiple programming languages to help you get started. Below that, you'll find quick clarifications on the possible responses and detailed explanations of the data available for that endpoint. Here's a helpful Ahrefs API trick. Instead of writing requests from scratch, use the interface. Each report, like the one for organic keywords, has an API button that lets you replicate the exact report via the API. From my experience, a few filters in the interface are still unsupported in the API, but the difference is minimal. Let's say I want to apply filters to fetch only keywords with a search volume of 1,000 or more and a lowest DR of at least 70 in the top 5. After applying these or similar filters, I can copy the URL or CURL for the request, depending on which method I prefer. The menu also conveniently shows the cost of the request per row. For example, fetching data for these 237 filtered keywords would cost nearly 20,000 credits. Not too bad, but if I were to run this daily for several domains, I'd hit the limits pretty quickly. As promised, let's move on to a specific implementation of the Ahrefs API. I'll create a backlinks monitoring dashboard that tracks backlinks obtained last week for each domain listed in a shared spreadsheet. The code will be written in Python, and the data stored in BigQuery and visualized in Looker Studio. If you prefer a written guide, we've also outlined this implementation in detail on our blog. To start, I've prepared a simple spreadsheet that's shared with my team. Right now, it includes our domain, along with those of our sister and parent companies. The key advantage of this setup is flexibility. The marketing team can update the spreadsheet whenever needed by adding, removing, or modifying domains. Each morning, the contents of this spreadsheet are synced to BigQuery using Coupler.io. This ensures that the script always runs with the latest domain list, even if changes were made at the last minute. Why sync to BigQuery instead of pulling directly from Sheets? While it's possible to use the Google Sheets API, it's not as straightforward and adds unnecessary complexity. Since all Ahrefs data will eventually be stored in BigQuery, it makes sense to centralize everything there from the start. This way, the process is streamlined and there's less room for error. The Coupler.io importer syncs data from the spreadsheet in Google Sheets to BigQuery. What's great is that you can also pull in data from dozens of other apps Coupler.io supports. For instance, you could fetch domains from Sheets and combine them with GA4 metrics to create a more detailed dataset for analysis. Once you've selected your data source, you'll get a preview of the data. Simple in this case, since it's just a list of domains. If needed, you can apply basic transformations like filtering or sorting directly within Coupler.io. For more complex datasets, you might want to add calculated fields or aggregate your data. When it's time to send the data to BigQuery, you can either update an existing table or create a new one. Make sure to set a schedule for your importer so that updates sync automatically. If someone adds a new domain to the spreadsheet, the changes will be reflected in BigQuery during the next scheduled refresh. Now that the domain list is in BigQuery, I can move on to my script. First, I'll import the Python packages needed to retrieve, process, and upload the data. I'll also configure the headers for my API requests, including the Ahrefs API key, which I've securely added to my environment variables. Next, I'll add a function to collect domains from the input table in BigQuery. The query below does some basic cleanup to handle inconsistencies, such as domains being added with or without HTTPS, trailing slashes, or other variations. As the list grows, duplicates can easily creep in, so this ensures everything stays clean. The function then returns a neat list of domains, which I'll later loop through. Next comes the function to retrieve backlinks for a specified target, domains in this case. The function focuses on backlinks added between today and exactly 7 days ago, which I've defined as previous date. A particularly handy parameter for this function is where, used for filtering. I've set it as a variable for readability, since it's a bit lengthy, and I'll reference it later in the params. Here's how the filtering process works. I'm pulling backlinks that are is content and come from domains with a rating of 25 or higher. Now, you'll notice I've set the threshold to 24.5. That's because both the Ahrefs interface and API responses round domain ratings. For instance, a domain with a rating of 24.7 would show as 25. By using 24.5, I ensure that I don't miss those borderline cases. I'm also only interested in backlinks from domains with traffic exceeding 500. And of course, I'm making sure the backlinks fall within my specified date range. Finally, filtering out null values in last seen ensures I exclude links that were added but have since been removed. Now let's go over the parameters and the rest of the function. I'm fetching backlinks added within the last 7 days for the target domain, ensuring they meet the conditions I defined in the where parameter. For the dashboard, I only select the fields I actually need. This is a smart way to avoid wasting API credits unnecessarily. Next, I pull the data from Ahrefs, handle any potential errors, and return the results. The sample response in the documentation for this endpoint is an invaluable resource if you're unsure how to extract specific data or want to explore additional fields. I've also added another function to fetch referring domain counts separately for each domain provided. This uses a different endpoint but works similarly. Here, I apply the same filters for DR25+ and the date range, retrieving just the domain and its rating. My focus isn't on the individual referring domains themselves, but rather on the count, specifically the total number of domains with DR25+ and those with DR80+. I calculate these counts by checking the length of the response for each filter. Finally, I've included a function to send the results to BigQuery. In this case, I replace the table each time because I only need the latest backlinks. If you want to maintain a historical record by appending results, you'll need to add logic for managing duplicates. This is particularly important if a link gets added, removed, and then added again. To tie everything together, there's a main function that runs it all. This function starts by collecting the domains from BigQuery and defining the date range. With many APIs, it's a good idea to fetch data for yesterday rather than today, as metrics for the current day might still be incomplete. For the previous date, I simply go back 7 days. Since the Ahrefs API requires dates in ISO format, I'll make sure to adjust them accordingly. I'll also prepare empty lists to store backlinks and refdomains data. Next, I iterate through each domain, fetching backlinks one at a time. For every backlink retrieved, I append the relevant metrics to the backlinks list, renaming some fields to make them clearer for analysis. I then repeat a similar process for the refdomains endpoint, extracting the 2 key fields for each domain and appending them to the refdomains list. Of course, I add some error handling too. Once all results are collected, I convert the lists into pandas data frames and send them to BigQuery, but only if there's data to process. Finally, the last 2 lines initiate the main function, kicking off the entire workflow. After running the script, the results were successfully exported to BigQuery. The final step is connecting these tables to Looker Studio. Instead of adding them as separate sources, which could hurt performance, I chose to union them. This approach also makes it easier to filter both datasets simultaneously using the domain field. To improve usability, I applied a few transformations. Timestamps were converted to standard dates since Looker Studio handles them more effectively. Boolean fields were converted into binary values, making it easier to sum them for metrics like the total number of do-follow links. Here's the unified dataset in Looker Studio. And here's the dashboard I built from it. By default, it shows all backlinks from the last week, but you can filter by domain to focus on specific data. I've also included DR and UR breakdowns for new backlinks, making it easy to analyze quality metrics at a glance. Now, let's circle back to the API limits and explore how credit consumption works. I've prepared a simple request to fetch all backlinks for a specific domain, referred to as the target in this API. Since this could return a massive amount of data, I'm applying filters to keep it manageable. Only backlinks with traffic of 500 or more, and at least 10 unique referring domains per URL. I'm collecting the following details: the URL of the page linking to us, the page on our site the link points to, and the traffic associated with each backlink. I had to consult the documentation to understand the costs. Unless stated otherwise, the standard cost for a field is 1 token. So for instance, URL2 costs 1 token, and URL from adds another. However, traffic costs 10 tokens, and ref domain source is priced at 5. That's 10 tokens for traffic, 5 for ref domain source, and 1 each for both URL2 and URL from. The good news is that you only pay for each field once, no matter how many parameters you include. So extra traffic doesn't come with an extra charge. And if you include a field in the where clause, you don't need to add it again to the select statement. In total, this request would cost 17 tokens for each backlink fetched. So for example, getting 100 backlinks would cost 1,700 tokens. But here's the catch. Unless you check the number of results in the interface first, you can't be sure how many you'll actually get. That's why it's often worth specifying the limit parameter, which is usually combined with order by. In this case, I'm fetching only the top link by traffic for each domain, which theoretically should cost just 11 tokens. But Ahrefs has a minimum request cost of 50 tokens, so even this simple request would actually cost 50 tokens. If you're fetching different types of data for the same target, one tip I can offer is to use the batch analysis post request. It lets you pull multiple data points with a single request, which can really help reduce your usage and save you tokens. The documentation provides more examples of how the pricing works. And if you're wondering about your current usage, but don't have access to that information in the interface, since only admins can see it, you can send free requests to the limits and usage endpoint. This will return the usage and limits for your entire workspace and the specific API key you used. It'll also tell you when your limits will reset. And that's it. Now you know how to use Ahrefs API efficiently. If you have any questions, feel free to ask them in the comments. If you enjoyed this video, please give us a like, share the video with others, and subscribe to our channel so you never miss a thing. Thanks for watching. I'll see you in the next video.